Hello, everybody. Welcome to my live stream. It's Thiago here, and today we continue in the URL shortener series, and we're gonna do some nice refactoring on our code and talk a bit about interfaces. So, so the agenda for today is we go through our in-memory implementation and actually start using the methods we implemented there and never use it. Then implement a proper struct to manage our database, and then start actually using and let's say discovering our interfaces, and then refactor the code to actually use the interfaces and allow us to switch between implementations easily. And if you have a bit more time at the end, maybe we start writing some tests. My dog says hi. Hi, Leo. And yeah, let's jump to the code. So if you all remember, we implemented this db struct that's like an in-memory database that has two methods, set and get, right? And then down the stream we added actually a SQL database, and we added directly to the handler the reference to the SQL.db. So that means that our handler actually has SQL code. So what we want to do first is, if you go back here, is actually use those set and get methods from then in memory. So we go back to in memory, use those methods, then we try to implement the same methods on a new struct to be our SQL database. So if we go to our first method, save URL, we parse the URL. Here we have the save in SQL, and we had commented out to save on the in-memory database. So let's uncomment that and comment out the SQL part. But instead of actually using directly the map, let's do h.db.set key and parse it URL. Parse it, not complete, thank you. So now we use our in-memory database. If we go back down, then here we have the same thing. That's the SQL DB, SQL DB. Let's comment it out. So do row scan and everything. Yes, so let's comment that out. And requested URL. We don't need that. And we have here read from the DB. Actually, here we read if get. So that's good. You have the get and you have the set methods being used. Request URL. My Emacs is not happy yet. Define it there. So should be happy. Let's restart the Go server. LSP restart Go please, and yeah. Okay. Still not happy. Whatever. That should be working. Oh. Direct land. Indirect response. Right. Well, I don't know what to know. Well, anyways. So that should use the methods we have on our DB struct, get and set. So let's test it. I have a terminal here. Yes, I have a terminal. So go run dot invalid argument requires URL type or URL for len. Oh yeah, that's true. So it's on our get method. That's down here. Actually, the type of requested URL is URL.URL, not string. So str URL column equals requested URL dot string. Actually, I'm gonna do that directly here. That could generate some issues if we get nil back, but let's handle that now. So if requested URL is different than nil, if requested URL is equals to nil, then return 404. We have here already the code, so let's copy the code, paste it here, and of course uncomment it. Okay, so if requested URL is nil, then return, and now we do the str URL column equals dot requested URL dot string, and let's choose it to go up instead of down. Very smart. And then I can delete both at the same time and do a str URL. So that should allow us to compile the code. Connection refused for the database because I don't have the Docker running. And we're actually not using the SQL right now. But for the sake of simplicity, I'm just going to start the Docker. So I have my sheet here, start the Docker database. Copy, nope. Copy, I don't want to. Terminal. Run, okay, Postgres database is initialized. Go run. We don't have the tables there yet. I created a new database, but we don't need them right now. So, okay, so let's quickly test local host, save. Let's do something different. HTTPS, tiago.live. And then you get the URL. And then, and they didn't put my browser to appear. No, cut browsing, you must not. And my shortcuts are overlapping. Yay. Host, go. Do I have it saved? No. Local host. Go. Char string true equals, and the code. It redirects to my website. Beautiful. Okay. So we have it saved. So if we go back to Emacs, just make sure we are actually using the in-memory. I'll stop the process, start again, and go back to the browser. That should allow us to actually, if you try to get it again, the local host 3000, Google Chrome Never Cache what I need. Go to the same one. We get page not found because we are using the in-memory implementation. It's not persistent. Good. That's what we wanted. If we go back to the code, okay. So we have those set and get here on this DB struct. That's the in-memory. So let's first rename it to something more meaningful. To in-memory. And let's create a new one. Type, let's call it Postgres. Postgres struct. And then it's gonna have a DB. That's gonna be a SQL DB. Actually, I'm gonna call it, just gonna call it DB. And on Postgres, we want to implement the set and get method in a very similar way that we have on the in-memory. And then we can remove that bit of SQL logic from the handler to this struct. And then later on, we can actually refactor that and start introducing other packages so we have our code better organized. So func to my p postgres, then get key string. It does an error. Return nil, just to have the both signatures here. P postgres set key, yes, key value string, and then it can return error. Type something, of course. Returns an error. Return nil. Okie dokie. So if we go down to our code, save, I'm just gonna copy the whole code back there. Save is set. So let's comment out and comment that code, and let's see what we can use. So it's not HTTP, is p.db exact context. So it means we need a context. Text context dot context. Parse the URL dot string. So the value, let's be of type string value. Let's call it value. So value. Insert key value. Not create variable error. Error needs to be defined. If error is different than nil, for now I'm gonna log it here, and then return fmt.errorf, not insert data, not insert data, percentage w to wrap the error, and my error, and if there are no error, return nil. Cool, we have set. So if we go down to the get one, get URL, so here we can copy the same thing. Log error, do we need something else? Let's just copy everything. Get. Okay. And uncomment everything. Requested URL string. So it's not HTTP, it's p.db. Variable context. I need a context here. CTX context, CTX, and context.context. What did it do? Yes, it's not X key, it's key. Okay, then we scan the rows. If row error, we'll leave the debug, we don't do HP. Return. For now, let's just do new error. mt.error f errors.new. fmt. Just be specific on this error. Not that's error on scanned no row. So we need a nice error message here. So no entry for key. Percentage q key. So percentage q is gonna automatically quote the string for us and escape anything that needs to be escaped. If it's another type of error, we keep the message, cannot read from database. I think that's good enough for now. We keep our logs. Later I'm gonna organize better those logs, but for now, let's keep them. It's better to be more verbose, especially at the beginning, than not have logs at all. And let's wrap this error. fmt.errorf. What can we write? Same thing. Cannot read data from database. Percentage W. Error. and that's get. So actually we don't return arrow, we return a string and an arrow. Because if it works, we return the URL. So here we actually need to return an empty string. Here as well. And here we do need return parse it or no requested URL and new, no error. So it seems we have our get and set methods implemented. Let's try them out. So the idea is to easily replace. How is called? No, good. Just checking my import. My go imports went a bit crazy. Okay. Oh, I don't have the logger here. Call 0 log.ctx. ctx. I'm gonna need that on my set. So I have my logger, I have my context. My imports look normal. And let's use that on our handlers, right? So we don't need its whole logic. So actually, let's keep those commented out. We don't need this comment. Saving memory. H dot. Oh, we don't have the SQLDB there yet. Our handler is not gonna have a SQLDB anymore. It's gonna have a Postgres. And then on your main.go, when we initialize it, the handler, we do a p, so Postgres DB, that is the DB connection. We're gonna organize all of this later. Create proper constructors and everything. For now, let's focus on getting the interfaces right, and then we organize the packages, constructors, and everything. So handler have Postgres. Handler has got Postgres, and here, that's the save URL. So saving NoSQLDB, so we do h.p.set x key parse URL dot string. Okay, so here we already see a difference between our set methods and our different database implementations, right? On the in-memory, we only have key and the parse URL. That's actually URL.url type. And on the Postgres one, we actually save a string and we also accept a context. And this one actually can return an error. So I need to do it's a set, so we can do directly like that. If error column error is different than nil, then I'm gonna copy everything we had here and comment cannot set into instead of SQL, let's call it Postgres just to be consistent with our struct and types. Then a error, blah blah blah, return. We don't need this code anymore. Then if there is no error, then we move on to NMSG to get the get method. So here we do db get requested URL, and then you do a str URL. So on our db one, we gonna do h.p.get, then the context and the key. if I'm learning how to type context, ctx, and our get method also returns an arrow, a string and an arrow actually. So str URL and error. Column equals, not column 1. What did they do? Column, no, yep, that's it. If error is different than nil, what do you want to do? If the error is different than nil, there are two possibilities, right? It could be no errors. My dog's very loud right now. Sorry for that. He's gonna be quiet in a second, hopefully. So we need this SQL no rows logic, and later maybe we need to improve that, and the return thing. I should have just a comment there, but okay. So if error is not nil, if error no row cannot find URL for token, return not found. If there's another error, cannot read from the database, and internal server error. Cool. And we already have str URL. Comment out everything. We don't need this len 0 anymore. And then return the temporary redirect. And it should be working. And I need to comment out this one. And this one. We only use the DB, the Postgres database. So we only use the Postgres database. So now we should have both using the Postgres database, and now everything's using the methods. Let's see if we got it working. Go run. And define the requested URL, 9189. Because that is str URL. And it runs. If we go to the browser, we can run this request again to save it. Internal server error, yay. Relation URLs does not exist. Yes, we didn't create them. Let's go to my day. Don't need to do that. Don't need you. That's terminal. So let's go to Postgres. Let's create the table. I forgot to create the tables. We need to automate that, but I'm leaving it for the kind of last moment. So we focus first on getting the code more organized and then work, and then we focus on automation around it to create a database automatically and insert create the tables and everything. So create table, work it. Control key, exit. There. Okay. If you go back and run, and we go back to the browser, and we refresh, we actually get the URL. Nice. And then you can try to go to it. It works. Let's go back to Emacs. Let's make sure that is persistent. Go run again. And if we go back, we should have the wrong one here, but we can put the right one. And it's working. It's saving on our database. Good. So back to main.go. Now we have two different database implementations with slightly different method signatures. So let's talk a bit about the difference here, right? So in memory, as you can see here, is saving a URL.url, while the Postgres database is only saving the URL. So we can actually just save a string here, and both are going to be the same. We have to update the data types here, string, And also here, because what we want to do is to see what interface we need to, if those two are actually similar enough to implement the same interface. And also the other difference is Postgres also receives a context, and there is an error for everything, which on the in-memory actually we can also have it, right? So the context would be for context cancellation, for logging and everything. So ctx context dot context. It's a good practice. Always receive a context on your methods, unless you really know that you don't need a context at all. And it can actually return an error, because if the value already exists, our poster is going to say, hey, that already exists, can't insert it, but the memory is just replacing it. So what you're going to do, you're actually going to check if the value is there. If the value is already there, we return an error. If the value is not there, we insert it. So how do we get that? So we can do, I don't care about the value if it exists. So underscore okay, I can exist. Equal key key. So that's gonna, to exist is a boolean when you use this kind of notation that you read from a map and get two values in Go. The second value is a boolean saying if the key was there or not. So if it doesn't, we want to we are inserting. So if it exists, so let's handle the error. And if it exists, we want to return an error. Yes, so we turn empty.error f. Key HQ already exists. Key. If not, to save and then return nil. Okay. And if we get the content, we can actually log it. Error. MSG. Exactly the same message. And then on get, we can do the same. Because if we don't have, if the key is not there, we don't want to return an empty string. So we'll just return, oops, just make it compile. But what we want to do is if, no, we need to value exist, I'll do okay. If not okay, if it now exists. Column equal t key. So if it does not exist, then log, get my logger here. Oop, what did I do? Logger 0 log.ctx that I haven't defined it. Context.context, because we want to be able to log our errors right now or cancel the operations on the map, but that's never gonna happen. Okay, so logger, something's complaining because it did a mistake on the other one as well. And now my imports are right. Okie dokie, back here to get logger, value exists. If it doesn't exist, I want to return, I want to log it. Logger.error msgf key percentage q does not exist. Return empty string errors.new t.error f. And if all good, then we return the value and nil. And that's not q, it's key. My memory should be working now. And actually now we have the same signature as our Postgres database. And now that allows us to start doing interesting things. So we can actually define the first interface, but let's first test it. Get set, where are our save URL? Why are you complaining here? I don't have context. Why are you complaining for the URL? It's string. Let's save it in memory. Yes. If we're in memory, and that actually returns an error. Let's comment. So now that we have exactly the same interface, we can comment out here. And if I want to use the in memory, I do db. And it should compile. Or P for Postgres. I'll leave it like that. Let's just go to get URL. I don't need commented out code. No, actually, yes. So it's not requested URL anymore. It's str URL r key in the context. It gets code working. I don't think that they're gonna get code working. Oopsie. Go here and define more variables. But I could just replace by db, save it, compile internet, compile it, doesn't complain. Should be working. Let's put back to Postgres. And if we go back to our handler, I just want to rename it. You rename man memory. Let's keep it short. So how can we actually, so we have our implementations, they are the same. So now let's try to define an interface. So let's have a type database an interface. So very quick about interfaces in Golang. So interfaces, as many other languages are, they're a collection of methods. So an interface in Go is going to describe behavior, the behavior of a type. So any type that has those methods automatically implements that interface. In Go, we don't need to say that a type, you don't need to explicitly say that a type implements an interface. So the database interface is gonna have a method set that receives a context key value string, and then returns an error. So this receives a string, not a string, and a get method. It also there's a context and get receives a key and then returns a string and an error. And key is of type string. Cool. We defined an interface. So let's see if we can actually use it. Where did we define a handler? Have here in memory and Postgres, right? So here I could do database. But just put those as database. Our code should still work. And I'm gonna quickly run in a second. So far compiler is not complaining. The go run, it compiles. So we have now everything on the handler is actually of the type database, which we can easily see in a very interesting way. Before we had the code like h.db, that's now called memory, and then you could do like key and access it. But now if you do, you get a compiler error. If I just do that and run, you see operation key type database does not support indexing because our database is now an interface. So the only way to work with that is actually to call the public methods of that interface that get and set. Right? And so, oops. And I'm getting confused with my key points. Okay, back. And if you go back to a handler, I'll put a third one and then clean up. That's actually called DB. That's a database. So the idea is our handler only needs to know about DB, about the database, right? And then when we instantiate it, then we can define, hey, here is your database implementation. That's gonna be a in-memory or a Postgres. So for now, I'll keep Postgres 1 DB. And then we define a constructor for that to do it properly. And refactor DB. Save. Don't need to save in memory anymore. Save URL in our database. Because now our handler doesn't know anymore if it's in memory or not. DB. There's the database and get the same thing. Let's clean up the comments. DB get snap redirect and quick test. Can we compile it? Yes, we can compile it. So now let's create a constructor and then start doing some refactoring. Sorry. How much time do you have? 20-ish minutes. Should be enough. Type Postgres. I'll leave like that. I want to create a constructor for the handler first. Where is your handler defined? Our handler is defined right here. Func new handler that returns a handler. Returns a handler. And then it's gonna accept a DB, that's a database. And return handler DB. Oh. You handle the handler. Beautiful. And now in our main.co, what we can do is just do everything. New handler. Then you're gonna put we can put a Postgres that receives that's my connection. And if you want the one that's using memory, just define for the sake of it. I'm gonna call it H. Just comment out this one. I just want to have both implemented here in memory. It doesn't need any argument. or compiler is not complaining. Or linters, compiler is also not complaining. But let's leave it commented out and let's keep using the Postgres one. So we have now it organized with an interface. And now we already have two implementations for this interface. Later on, we can even use this interface to do some testing on our handler, because then we are going to be able to actually mock the database implementation. And now we have everything on our main.co. It's getting very, very messy. So let's create a new package called, for the database. I'm thinking between database and DB for short. I'm gonna call it DB with a postgres postgres.co. Make it directory package DB. What I want to do here is to move the Postgres implementation to that new package. Actually, I'm gonna cut the whole code. Main.co is not gonna compile for a moment. And Postgres, let's LSP rename. And let's make it public, exported. Postgres, and then because of course Postgres is a the DB is not exported, because the internals of Postgres is not exported, we need constructors. So let's do it directly. Func new Postgres. It's gonna receive for now I'm gonna receive the connection on this SQL pointer sql.db and then returns a Postgres. And then return Postgres and the new Postgres from the other one. DB. Cool. So now our main.co. Let me get just one. We can clean up our main.co. We initialize the connection, and now instead of having Postgres here, and you can do db.new Postgres and then pass the connection. And then we have abstracted away our database. And for the sake of consistency and simplicity, let's also create a new file there called in memory. DB, and let's put our in-memory implementation here. No. Same thing, let's go to main.co. Let's copy our in-memory implementation. And then when I finish copying, let's talk about interfaces. Save it, same way. P rename. I want it exported from new in memory that returns in memory return in memory. Now in memory is still a map type. I'll leave it like that for now. Okay, so let's see if your code still compiles. If you have an error. No, good. Let's go. We are now on main.com. Okay, so let's talk a little bit about interfaces here. So where to define the interface? That's a big question. There are different ways of seeing that and do that. But one that I actually very much is for your methods in general, especially your constructors, to always accept interfaces and return concrete types. And I think I have a quote for that. Nope, not for that. Anyways, so the idea behind that is if you accept interfaces and it returns concrete types, then your methods, they are generic in the sense that anything that can behave as you need, then you can accept. So anything that implements the methods you need, it can be passed for your method, right? Like SQLDB is actually, it's not an interface, it's a struct, but we don't have an interface for DB. We could even work on that later. And we return a concrete type because then you say, hey, wherever it's calling me, here is my type. That's what I can return to you. And then you use it in the best way possible, right? So you have this flexibility. Right now we're still receiving the concrete type here, that from the standard library, but we could actually later on define an interface to have the method receive anything that can behave like a SQLDB. Or then if you know like that's a Postgre implementation with the SQLDB package, you can also be very explicit. Hey, I need the concrete type. But for like in our handler, on your main.go is a good example in the constructor that says, hey, I need a database interface. Doesn't matter if it's Postgres, if it's disk, if it's in memory, if it's SQLite, MySQL, MongoDB, whatever. Just want a database that can do set and get. And then where do we define this database interface, right? If you define that in the package that actually uses, like for example here, the handler, we have the database interface defined on the handler, then you decouple your handler for any kind of thing. So your handler doesn't need to know actually about which database implementation exists or which package defined the database interface. Says, hey, I need something that can set and get, can set a value and can get me a value based on a key string, return string, and arrow. Anything that fulfills that, you can pass to me. So you make your handler more generic. And then later on, you can do whatever you want. You are totally independent. That's also a very good thing when you implementing code and using external libraries. Usually, if you can define an interface, and then instead of accepting the concrete implementation of the library, we accept your interface, like a database implementation. I mean, that's a good example. Instead of accepting a type from your DB package, we define our own interface. So our handler is fully independent. If we just refactor this handler in another package, then the package handler is fully independent. Everything that it needs, it's defined within the package. It also works as a way of like documenting and being very explicit about what you want. Because when you define an interface inside the package, like, hey, that's what I need to work, and that's it. Like in this case of database that needs something that can get and set. Wherever implements it, it's going to work for me. And also I'm not going to force any like independency with any other package to implement it. So then let's see how our code looks like. We have a new handler database. In memory, how long have we been here? We have been for almost an hour already. I don't want to go much longer than an hour. So we created our package, we had our interface. So we keep the definition of the interface here. Next time we're probably gonna refactor a bit more the code, split the handler and the main package. But then as we refactor, let's just do a few more refactorings. I'll add back this user agent and refer to the logs. This mirror is not a nice name. It's actually a logger mirror. So it's p rename request logger. What else do we have here that we can clean up? Login initialization, I'll leave it like that. Database open, I'll leave it like that. So new router, new 11.0 log, request ID, remote address, user agent refer, then our request logger, then we defined everything, our route, we log in everything. Cool. So save URL is to use the DB as it should. The cat is using the DB as it should. So let's go to terminal. Let's make sure our code still works. Clicks for the Postgres database. So the Postgres database, don't remember anymore. So if you do this one, yeah, this one doesn't exist on the Postgres database. Yes, so, and of course I didn't put the browser, so let's start again. Let's go to the browser. I still have my key for my Postgres database here. And then if you go to that URL, we can navigate. We can also save a new URL. https://golang.org. And you can navigate to this one as well. Go host. Go to. That also works. So, and then if you go back, Emacs, we see our beautiful logs. We have request started, and then you have everything: method, IP, request ID, user agent. I don't think we have refer now. Not set. But yeah, we have everything. Our code still works. And that was it for today. Talking about interfaces, refactored our code, and we have our database abstracted away, and the database interface defined here. But next time we're gonna keep working on refactoring and then adding tests, because testing it manually like I'm doing like here, it's definitely not the most practical when you have a big project or doing lots of refactoring. You should just be able to do go test and be sure that everything's working. So that's gonna be the agenda for the next probably couple streams. So I hope you enjoyed it. I hope you learned something today. And follow me on Twitter. The link is in the description of the video. And see you next time.